Okay, so this is a week number 6, valence bond theory. So use a Vesper model to figure out what kind of compound does have a how hybridization in the central atom occurs. Okay, so hybridization in the central atoms for antimony pentachloride. So antimony pentachloride, antimony means Sb, and chloride, is chlorine. It has a 7 valence electron, and there are 5 of them. Antimony, if you look at the periodic table, is on the 5th column. So what it means is I'm going to use my shortcut way, 5 valence electrons, and you need 5 electrons to make bond with 5 chlorine, and there is nothing left. So therefore, no lone pairs, 5 bonds. So therefore, number of electron groups are 5 Eg. So when you have a 5 Eg, that means you have structure-wise, once again, trigonal bipyramidal structure. But let's just focus on the question here, which is what kind of hybridization. 5 means sp3, that so far it's a 4, and d hybrid. So that's what that means. And then they actually, I want to go elaborate a little bit because I use an orbital diagram. So let me show you some energy diagram. So this is an energy level, and that will be an S. P has higher, but there are 3 degeneracy, and the D has a higher, so I guess so it has a 5 degeneracy for P and the D orbital. And the hybridization for 5 Eg, 5 Eg means 5 Eg means you are going to have 5 orbitals. So this is so far like this. So that makes sp3 dehybridization. So by doing so, this new energy level here is, remaining 4 d orbitals are there. And let me put a different color. So you have a 1, 2, 3, 4, 5. That's a sp3 d hybrid orbital shown up here. And then now how many the valence electron the central Sp has? And that one is 1, 2, 3, 4, 5. So this is how they occupy in this sp2d hybrid orbital, and this, I guess this compound is a paramagnetic. So let's continue to quickly on to the second topic, which is a selenium dichloride. Selenium, if you look at the column, the selenium means the column on the 6, and once again you have a dichloride, the 7 electrons. So once again, the selenium 6 electron means you are using 2 electrons to make chlorine, 2 of them, and so then what's left over? You have a 4 electron left over, and that 4 electron will be paired up to make 2 lone pairs. Okay, this is what I mean by LPs. And then 2 lone pairs, good. And then this one is 2 bonds. So if you add them together, EG, which is a lone pair and the bond number, that's a 2 plus 2, which is a 4. So if you have a 4 means 4 Eg means hybrid orbital, sp3 hybridization. That's all the time. Okay, so that's what it means, and that's hybrid. And then I am going to draw the same kind of orbital diagram. This time This is an energy level, just like I have done that before, energy level. But this time I only need to consider those S and the P orbital only, because that's a sp3 hybridization is what I need. And so you're going to essentially combine them to make hybrid. And the energy level will be, in a way, if you think about it, that's somewhere in between, right? I'm going to put the dotted line. That's where you have a 4 sp3 hybrid orbital that has the same energy level. Okay, so this is the same energy level. And then selenium wise, so let's 4, so Eg4 means tetrahedral structures. So it looks like this. Selenium is in the center, so we can actually, it should be looking like this. And then you have 2 chlorine. Chlorine is up there, and then 2 lone pairs. Okay, so this is how it looks like. So some people would draw something looks like this, and it has a bent molecule structure or V shape. Somebody will say V shape. Okay, and so on. Well, why am I doing this? Is because I need to kind of complete my diagram. And how many electrons the selenium has? It has a 6, right? So you got 2, 2, and then there's a bond and bond. One of each electrons are being used. So that has a selenium has a 6. So 1, 2, 3, 4, 5, and 6. So this is a hybrid orbital diagram for this. Okay. So once again, this concludes the valence bond theory on using this Valence Vesper model. And then they wanted to how the hybridization occurs, and they showed how electrons are filled in the hybrid orbital.